Our next lesson, this is Dr. Stephen Harkins. Our next lesson is fibrous connective tissue. Recall that the last lesson was epithelial tissues that were on the surface of things, on the surface of the skin, lining the surfaces of ducts and glands and the openings of things. But fibrous connective tissues are different than epithelial tissues, and we're going to find out exactly how. Well, let's give you an overview of what we're going to work on. There are 4 basic types of fibrous connective tissue: loose areolar, adipose, dense regular, and dense irregular. There are cells in these tissues, different types of cells. The main type is fibroblasts, macrophages, fat cells, plasma cells, and mast cells, and we'll go over each of them. These fibroblasts are the type of cells, they make certain kind of fibers. They come from these cells, collagen and elastic fibers. Also, in all of our connective tissue, they need to have blood supply, so they have capillaries, which are tiny little arteries, tiny little blood vessels that send blood to these areas. Let's start with loose areolar connective tissue. Right here. And as the name connotes, you notice compared to some of these other connective tissues, it is a looser sort of matrix. It's got lots of goodies in here too, starting with this little guy right here, this little cell. Here's the nucleus of a little funny looking cell called a fibroblast. And as its name connotes, it blasts out fibers. Collagen fibers here, elastin fibers here, or elastic fibers here. And here you have a description of fibroblasts. They secrete collagen, they create collagen, and which are very, very strong tissue, hard to pull apart, and elastic fibers, or from the protein elastin. Another fiber, another cell you'll find is a fat cell. You might find a fat cell in some of the loose areolar connective tissue. Here's an example of a fat cell right here. You can see this, the nucleus of the cell, and here's the cytoplasm of the cell. Look what it contains, a whole lot of lipids. That's a fat cell for storing lipids, which give us energy, right? When the body needs energy, it breaks down your fats. There are other cells found in the loose areolar matrix, or in the loose areolar connective tissue. They are immune cells, starting with this one right here, called a macrophage. A macrophage, B, right here. This little guy is great. He runs around, he's mobile. He runs around this matrix here in the connective tissue and eats up all the debris, all the trash. You'll see right here, where is our description? There it is right here. Mobile macrophages engulf cell debris, foreign matter, and microorganism. Anything that tries to invade you, it's part of the immune system. This guy will move around and eat it up. The second kind of immune cell that's found in the loose areolar connective tissue is called a plasma cell. It doesn't run around and eat things up, though. What it does is secretes antibodies in response to infection. So it's right here, this guy right here, and he secretes antibodies or proteins that will attack foreign substances or microorganisms. The third type of immune cell found in loose areolar connective tissue is a mast cell. Mast cells secrete histamine for inflammation. So when you have allergies, you can blame these mast cells. They're the ones that are secreting histamines. That's why you take, see, they're involved in allergic reactions. That's why you take an antihistamine. It's because of these guys right here, the mast cell. Well, all of our tissues need blood supply, right? So here we have a capillary. You can see right here, bringing blood to the loose areolar connective tissue. And the blood will sort of seep out of the capillaries into the matrix. The next type of fibrous connective tissue is adipose connective tissue. Adipose. It is fat. That's your fat. You know, I talked about a fat cell over here, right? And loose areolar. Well, adipose tissue is full of exclusively, almost exclusively, fat cells. And they are filled with lipids, fat for energy. Once again, you can see the cell body, or the nucleus right here. And of course, when our body needs energy, it goes in there and it takes out this fat and it breaks it down for energy. Adipose tissue is also, along with fuel source for energy, it insulates, it pads us. It pads us from harm. As you know, your fat protects you from harm, but also keeps us warm. It's an insulator. And mechanical padding. Also fat-soluble vitamins, A, D, E, your vitamins, they are all stored in fat. Perhaps when we think of connective tissue, the most common thing we think of is this dense, regular connective tissue. Notice how the difference between this tissue here, how it runs in parallel, these long parallel strands of collagen and elastin, collagen and elastic fibers. And notice that these long strands of proteins, collagen and elastin, make it very, very strong, and the fact that they run parallel. Now compare to here, where this loose areolar tissue, that doesn't look like it's good for a tendon or strong enough for a tendon or a ligament. Neither does this adipose tissue, but look how strong and tough this looks. So that's the dense, regular connective tissue. Now, dense regular does contain, as does loose areolar, fibroblasts. Where are they? Right here. Here's a fibroblast right here, blasting out the fibers, laying down these fibers. Here's the cell body, creating these long strands of elastin and collagen. It also contains, well, our bloods, our ligaments and our tendons need blood too. So here's a capillary, right? And the capillary provides blood, and the blood will leak through this nutrients will leak through the capillary wall into the matrix of the tendon. or ligament. Lastly, dense irregular connective tissue, and you can see why it's called dense and irregular. Compare it to the dense regular here, and you notice it's irregular. It's kind of scattered about, but it's more dense than, say, adipose tissue and loose areolar tissue. And you can see these strands of collagen running through the dense irregular connective tissue. And where we find these dense irregular tissue, connective tissue, is in joints. I'm going to draw a picture, my idea of a knee joint here. Here's the femur. Here's the tibia. Your shin bone. Thigh bone, shin bone. And every joint is covered with a joint capsule by an airtight joint capsule. And this capsule that keeps the joint nice and airtight is made of dense, irregular connective tissue. Not as strong as your tendons and ligaments. And you will have, say, your medial collateral ligament running over here, which is made of what? Dense, regular connective tissue. But the capsule that directly surrounds, encapsulates every joint in the body is made of dense, irregular connective tissue. Now, important for you massage therapists is that dense, irregular connective tissue also makes up the fascia, the deep fascia that surrounds every muscle in the body. It's a very thin layer of tough tissue, not as tough as tendons and ligaments, but it's a thin layer that surrounds and envelops and encapsulates muscles and organs. And a lot of therapists do well by working on the deep fascia of the body. And when they do, they're working on dense, irregular connective tissue. Dense, irregular tissue also has within it capillaries. Here's a capillary right here to supply blood and nutrients, blood supply for the joint capsules and for the fascia. And that concludes fibrous connective tissues.